everyone. The aim of our experiment is to find the image distance for varying object distances in case of a convex lens. Here, materials required are an optical bench, a thin convex lens, and a lens holder, a holder to place the candle, a candle, a meter scale, one matchbox to light the candle, and a drawing board. On this drawing board, I have pasted a white paper. I have used it as a screen. Here, the thin convex lens, this lens forms a real image when object is placed between infinity and focus. And if the object is placed in between lens and focus, then it will form a virtual image. So now we'll perform the experiment. I have placed this lens 50 centimeter from the origin, and this candle I have placed 15 centimeter from the lens. I am using a 10 centimeter focal length lens, and here the image will be formed beyond 2f, because here the object is placed between f and 2f, so image will form beyond 2f. Now I'll bring this screen nearer to the lens so that I will get a clear image. At this point, I am getting clear image of the flame. So this is the point where I am getting a clear and sharp image of the flame. I'll mark this point with the pencil so that I can later measure it. So I have marked this point. Now I'll measure the distance of this point from the lens, and this point and this distance is coming out to be 30 centimeter. So observations and calculations for this experiment are: here the focal length of the thin convex lens we have used is 10 centimeter. The height of the candle flame was 2.5 centimeter. Here the position of optical center of lens was 50 centimeter from the origin. The position of the lighted candle, which is denoted by C, was 35 centimeter from the origin, and the position of the screen on the other side of the lens, which is denoted by S, was 80 centimeter from the origin. And here the distance between lens and candle, which is denoted by X, which we'll get by doing L minus C, and it is coming out to be 15 centimeter. And distance between lens and screen, which is denoted by Y, and we'll get this by doing S minus L, and this is coming out to be 30 centimeter. The height of the image we measured was 5 centimeter. So here in this experiment, our magnification was 5 upon 2.5, which is basically height of image upon height of object, and which is coming out to be 2 centimeter. The magnification we are getting is 5 upon 2.5, which is 2. Basically this is height of image upon height of object. So this is 2. So the result for this experiment is, here serial number 1, the distance of object was 15 centimeter, and the distance of image we are getting was 30 centimeter. In this case, the object was placed between f and 2f. We can also perform this experiment when the object is placed between f. This experiment can also be performed when the object is placed beyond 2f, and in that case we will get the image between f and 2f. The precautions for this experiment are: the lens should have small aperture. Second, the base of the stand holding the lens should be parallel to the measuring scale. Third, the flame should not flicker, or you should switch off the fans to perform these experiments.